All right, hello everybody. My name is Ethan Glynn. I'm from northeastern Colorado on the plains, and today I would like to tell you about my devastating data discovery for Dusty December 2021. So picture this, younger Ethan, he's chilling in high school, geeking out in chemistry class. He looks out the window and he sees the biggest dust clouds he's ever seen, similar to the ones in the image below. It looked like the dirty 30s outside. Now these dust clouds, they had devastating effects on Colorado. The interstates were closed, highways were closed, flights at DIA were canceled and delayed, lots of people lost power, and there was lots of property damage from the winds of the storm. But the biggest reason I wanted to investigate this dust storm is because I saw the effects it had on the agriculture of the plains. During 2022, a lot of crops did not come up, and the grazeland for cattle was not the best quality. So I wanted to find what caused this dust storm so we could try and prevent it in the future. So coming in at the start of the summer, I knew nothing about coding, so that was a big learning experience for me. I used two main methods, RGB satellite imagery. All of my satellite images comes from this GO-16 satellite, and I also did an airport data analysis all using code. So RGB may sound intimidating at first, but it really isn't that bad. RGB stands for red, green, blue, and what I did is I did an RGB color additive synthesis. So this image on the left is a true RGB. It's what we see with our eyes. And as you can see, it's kind of hard to tell the difference between the clouds and the dust. And the image on the left, when you edit the RGB, you can see there's a clear distinction between the clouds and the dust storm. So here's my image. The one on the left is the true RGB, and the one on the right is the edited RGB image. So let's go over what we're looking at. So all this yellow you see is thick clouds. These green splotches are thin clouds. All of this pink is dust. And right here we have some cold, thick clouds. So if you take a bunch of images from the satellite, you can make a GIF image and get a better understanding of what path the storm took. So as you can see, the dust is in Colorado, Kansas, and Nebraska. What caused this storm? There was a cold front in the Rocky Mountains at the exact same. Lots of warm air was pushed up from the Gulf of Mexico, which caused a bunch of instability in the atmospheric trough, and all of that energy was released. And if you look closely here at this cloud formation forming, that is called a derecho, and it's basically a massive thunderstorm, and it hits Iowa later in the day and causes 120 tornadoes. And then time is in 20 UTC. That's a 6-hour difference from Mountain Standard Time. So this is at 2 o'clock in the afternoon. So this satellite imagery is good for a bird's eye view, but I also wanted some data from the ground. So I took data from my local airport, Sterling, Colorado. It's at almost in Nebraska, the northeastern part of the state. And I started off by downloading 10 years worth of data. And when I came in an Excel sheet, and there was 250,000 rows of data to go through. So I had to do this process called munging, where you get the data down enough so it's easier to analyze. So the graph you're seeing now is much shorter than what it started out as. It's just the year 2021, and it has two variables, wind gust in miles per hour and wind speed in miles per hour. Now, in case you can't see it, let me help you out. Towards the end of 2021, where that star is, there is an anomaly. So what I did is I just looked at the month of December, and luckily the 15th is the date of that anomaly, so I could break that down even further and get the maximum wind gust speed and the maximum wind speed. So what are the results of this dust storm? The December 15th was an anomaly. The maximum wind gust was 68 miles per hour. The maximum wind speed was 53 miles per hour, which is almost hurricane level wind speeds. But what I found most interesting is that there has been very, very little research done on dust storms. We don't know what causes them and where this dust came from. But while I was doing research on that, I discovered the composition of dust in Boulder is made out of phosphorus, copper, zinc, lead, and cadmium. So what does future research look like for dust storms? Well, first we need to figure out the differences between urban and rural dust. Because, so rural dust, there could be more nitrogen and phosphorus because of agriculture, but if there is metals in dust and we're breathing in those metals, that probably isn't the most beneficial for our health. However, there could be ecosystems that are lacking these essential elements, and dust could blow those elements to those ecosystems, benefiting the ecosystems. So I would like to propose doing research on a dust cycle or a dust budget, where there's a certain amount of dust that is blown across America each year that benefits everything. And we should also see how agriculture plays into this dust cycle and dust budget, because when you are harvesting crops, it's typically driest, so there's a lot of dust when it comes to harvesting crops. I would like to thank my mentors, Jen, Ash, and Megan, the RECCS leaders, Alicia and Dana, and the RECCS interns, hey! The ATOC REU interns, and the ATOC grad students. And before I go, if you scan this QR code, you can see all of the dust gifts I made this summer. My references are there, and there's a link to my GitHub, which is where I used the code. I simplified it so you too can make your own RGB satellite imagery. And then my email's there, and if you just don't want to scan the QR code, you can email me and I'll send you the link. Thank you for your time, and is there any questions?
Something that you chose, or was it kind of coincidence that this kind of related to the storm you saw when you were a kid?
No, this is something I chose.
Oh, awesome.
That's awesome.
I love it.
Leah, I saw your hand.
Yeah, what's a typical wind speed on like an average day?
For Colorado,
Yeah.
I would say a normal wind speed 15 to 30.
Oh.
And so in Colorado, during this storm, the maximum wind gust was measured at Lamar at 107 miles per hour.
Ew. Wow. Oh, no. I would fly.
Maddie?
Do you believe, after this research, that dust storms in general might play a key role in natural ecosystem management?
Yeah, I would say so. Like there has to be some correlation there. Mm-hmm. Yes, you.
Have you looked at anomalies at different times of years and when you have different types of vegetation, vegetation?
No, but the reason I chose 2021 is because it was a very bizarre year. It was super dry that year, and also we had the Marshall fires at the start of the year. So I think that had a big part of why there was so much dust in this storm. But we don't know exactly where this dust came from. The only way we would know is if we did an isotopic analysis. But since we don't know where the dust went, that'll be pretty hard to do.
Yeah, no one like.
You need Wookiee skills.
I'll hold my dish out.
Yeah. Yeah.
Ethan, is the airport data open access, or did you have to write someone an email?
No, it's open access. You just go to NOAA's website.
Cool.
I would love that email, like, can I please have your wind data?